Okay, hello everyone. Welcome to the Fuel Network Immunify office hours for the Fuel Network Attackathon, where we'll be discussing the this week news, updates, and experiences from both, three sides, from Fuel Network side, from Immunify side, and of course from your White Hat and Security Researcher side. So, we have three people from Fuel Network today. I'm your host, Adrian. I'm the head of triage. So if you're going to have any questions regarding the triaging, how we're handling certain things, or what should you do when I have something and I don't know how to write a POC, I'm here to respond to any such questions. But we also have Green here. Please introduce yourself.
Yeah. So hello, I'm Green. I'm team lead of client team responsible for Fuel Core and Fuel VM, which we're trying to break. Yeah, if you have any questions how VM works or how core part works, you're welcome. Yeah.
Okay, thank you. Next, we have Jibril, and I hope that I'm pronouncing your name correctly.
Well, you did, although I don't know why. Does my microphone work? I'm
Yes.
not sure.
Yes, it does. It does.
So I'm Jibril. I'm the team lead for the compiler team working on Sway, the smart contract programming language that you guys are also trying to break. So I guess same as Green. If you have any questions that relate to Sway, I'm your guy.
Awesome. And last but not least, we have Rafael.
Hello, guys. Very happy to be here to answer your questions. I'm the smart contracts specialist, and I have been in charge of developing the whole bridge in the last year.
Impressive. Okay. Thank you for joining. And yeah, I just want to start from a general question to you guys from Fuel. What is your experience so far reviewing all the bug reports? Have you already noticed something interesting that was previously missed by the auditors?
Yeah, I will start. Currently, yeah, first of all, it seems that most of reports are related to smart contracts, not to the VM or client part. It is sad. We hope people will try to break us more. But yeah, regarding findings related to client, there are some. There are like some findings that auditor missed. What is nice, but and they own Fuel VM part. Most of findings currently are related to DOS, and just I wanted to remind that please also double check when you submit your finding for DOS vector. Please double check our GitHub because we already described a lot of DOS vectors there, and if it is there, then maybe it's not eligible for a reward. But again, you can continue try to do that because there was one nice finding that revealed some other parts what we was not aware of. So it's not a bad vector. But at the same time, I wanted to say that we continue. So we have external firms what are auditing us, and we continue doing those audits during hackathon as well. And they found some critical issue on VM side. So I would suggest it's like I think you will find more on VM part or on executor part. Like Fuel Core has many crates. Some of them are publicly available, like external. Yeah, let's say external. But they're also like internal part, like Fuel Core executor, Fuel block importer, and I think there could be some bugs that you won't try to find, because in that case, if you will find something, you can create a fork for the network, and that one will be critical for the network.
Okay,
Yeah,
amazing.
Just like suggestion.
I mean, that's an amazing suggestion. So, guys, please start hunting on the Fuel VM. You will find more bugs there than in other sections. On Monday this week, on one of the technical walkthroughs, we are with Hexians and auditors who did audit the bridge, and they also mentioned that from their own perspective, probably more bugs will be on the Fuel VM side, because bridge was thoroughly audited and there isn't that much to it. I mean, there is still lots of functionality and logic there, but it's not something that wasn't seen before. So if you want to find something interesting, something unique, something that actually will yield you some rewards, Fuel VM is definitely a place for you to find those bugs. Okay, we have a question from Wizard. So we should focus on Fuel VM and core any other place.
Yeah.
What about us?
I let's say that suggestion was for people who are trying here to DOS currently Fuel Core. So if you're trying to find something on Fuel Core side, then your suggestion will be look more into execution of blocks, not into GraphQL API or P2P, and into Fuel VM, because it's also like part of the Fuel Core. And if you want to find something there, then I would suggest go there, because there definitely should be more valuable stuff.
Well,
Okay.
I'll definitely agree with Green that the VM is like the more fundamental thing. If you manage to break that, it can be worth a lot. But I will defend my own thing and say, yeah, come break Sway, come break the programming language. We can have critical bugs too.
Yeah.
Damn it. Although I will say we had a couple of reports, but one of the issues that we've been having is some of the reports have been hard to reproduce. So if you do report on Sway, try to be very specific in the POC that you build, because it helps us a lot. Like, there's lots of moving parts in the language, so having something that can easily be reproduced is a lot better from our side.
Okay, that's interesting. I mean, yeah, of course. I mean, a compiler itself is really important part of any new language. I mean, last year we learned from Viper bug exploit on the compiler level how important such bugs can be.
I've never been able to sleep after that.
I imagine. I wouldn't either. But what is your recommendation in terms of writing POCs for compiler bugs? What you would like to see as person on the receiving end of such bug report that would actually make you think like, wow, this is a really good written bug report on a great POC?
Okay, so if you have something that is, the problem with compiler bugs is that it's often something that can be exploited related to some other thing. What I would really like is if you think something is of a high severity, you build something that can actually do the thing that we fear might be done. And also, if you can provide the specific version of the compiler, of all the tooling that you're using to do this, although it should be the latest one, and just like your entire project, because sometimes even like if you just have a small excerpt, it might not reproduce the exact conditions of the bug.
Okay, and can you give an example of building that stuff that someone may be testing? Meaning like deploying a smart contract onto the network and later seeing if the logic that is actually there will make the execution of the Sway different than it should be compared to the documentation?
All right, yeah. I can actually give you an example, although this is going to be like a free one because it was reported by one of the audits, so you guys don't get to report it. Some of our static analysis in the compiler actually didn't take minting and burning instructions into account for the analysis. It's like we have this static analysis that validates the CI pattern, checks effects interactions, and tries to warn the developer against introducing reentrancy vulnerabilities. And we didn't check for that particular change of state. What would have been nice in terms of a report, if you had to report it, would be to have a contract that actually introduces a vulnerability and doesn't have a contract that introduces the vulnerability and where you show that the vulnerability exists and where it doesn't have the warning.
Okay, makes sense. Any questions regarding this part? I know that there is one question from Wizard, which we'll tackle in a minute, but before we go into that direction, are there any questions regarding what our Wizard just left? But still gonna, here you join, good. Was gonna tackle that question, but anything regarding what Jibril has just said? Let's give it like 1 minute for people in the chat to be able to type the question in, but yeah.
Yeah, also want to mention that sometimes to reproduce some issue, let's say if compiler has some issue during cross-country calls, then yeah, it would be nice if you will use Rust. Svay repository contains many examples where they deploy the contract first, call it by using Rust SDK. So yeah, if you could also provide like Rust test, which will deploy contract, maybe transfer some balance if it is required to produce an issue, and yeah, script that actually will do that, it would be nice as well.
Okay. I hope you guys are making notes. Okay, there aren't any questions to what we just discussed, but let's tackle that question from Wizard. What about standards and libraries? Are these tight, or maybe we should also pay attention to the implementation of the standards?
Both are definitely something that could contain vulnerabilities, and yeah, if you can find some serious bugs in that, especially the standards library. The standards, I'm less, I mean, it's still important, but I think it's probably less likely that there's stuff in there. But yeah, the standard library, it's stuff that everybody uses. In particular, some of those parts that are extremely common in the contract. So yeah, it's worth having a look, and there's probably some vulnerabilities in there that you can find.
Okay, awesome.
Although I hope, obviously.
Yeah. One thing from Immunify side regarding compiler bugs, when you're submitting bugs, remember, this is like a general advice, which applies to everyone, but when you're selecting an asset, which is like, for example, under smart contracts, and it may be also, for example, for a compiler, that means that you also need to select an impact from the smart contract impacts. And do not write custom impacts only. Always make sure to select the in-scope impact, and if you want to add additional information regarding what that bug can lead to, please write an additional custom impacts or include that in the bug description, because otherwise your bug may not be escalated because it doesn't contain an in-scope impact. But the compiler is under smart contracts because the compiler of Sway, which is a Sway is a smart contract language, will in most cases lead to smart contract impacts that we have listed. So remember about that. Another thing that I would like to ask you, guys, is regarding, for example, Fuel VM. So back to you, Green. How would you go about recommending someone who just learned about Fuel Network Attackathon yesterday, and he saw the really large code base, but he knows that, hey, I want to check into Fuel VM. I have vast experience in EVM, but I want to bite into Fuel VM. So how someone like that could start potentially finding some issues? Is it like mostly checking how EVM and Fuel VM are different, and how they're executing things differently, and trying to find some discrepancies there? Or there's another way to actually finding such issues? What would you recommend to such people?
Yeah, like I want to highlight that maybe we forgot Raphael, but yeah, we can return to him later. So yeah, about Fuel VM. yeah, let's say, yeah, I would say that it will be hard to compare it with EVM, because like because we have like different structure of memory. We, for example, don't support delegate calls or static calls, so our frame handling is easier. Yeah, like, and I think that comparison is a good thing. Yeah, like I would say that like, of course, the best place to start like understanding how VM works is to go to interpreter.rs file, and there is a transact function. Transact function, it is function that is used to execute any transaction inside the Fuel core, inside the Fuel core executor, and it's like its entry point for transaction is execution. And there is like init script. There is init script function that like prepares VM for initialization, and like for example, yeah, it may reset. Like currently, we don't reuse VM. We don't reuse the same VM many times. We create a new VM each time, but we reuse memory for VM. So, and inside of init script function, we will reset memory. For example, maybe memory has some issues you can look into. Also, we like initialize all required registers, like registers where to start execution, SSP, GAS registers. So yeah, maybe there could be some problems. And also you can like compare it with our specification, because specification tried to describe how it should work. So if there is a difference between specification and implementation, maybe it's a problem of implementation. In most cases, it's the problem that we forgot to update specification, but sometimes it's also a problem of implementation. Yeah, and after initialization, we will call run function, and run function inside handles currently 4 supported transactions. The main one, I would say, script. And yeah, if you will go to the script, we also like do some small preparations before we will start script execution. And there is like main run function that will, in the infinite loop, will run each opcode one by one until it returns or GAS is over. So yeah, it like main cycle of VM. And there, like, yeah, for each opcode, we have, I don't know, 50 opcodes. For each opcode, there's like a handler of corresponding opcode. So yeah, it has like inputs. Like if it somehow affects state, it like you can see that through the input arguments for the handler. For example, if opcode touches somehow storage, that means that there will be mutable storage as an input. If it only verifies something, like, I don't know, get balance, for example, your balance opcode, then it only will take read-only storage. So it's how you can try to understand what is used inside of that opcode. And of course, like, specification contains description how each opcode should behave. And yeah, if you see some differences there, then yeah, it will be a problem with specification or problem with the code. Yeah, and there, like, all part of opcodes, maybe 10, somehow interact with memory, maybe even more than 10. Yeah, they somehow interact with memory, and there are like when we execute those opcodes, we verify that they don't violate any memory ownership rules. Yeah, memory, it accesses, yeah, opcode touches memory that can be accessed, because yeah, some parts of memory are inaccessible if they were not initialized. And there also could be some bugs, because, for example, yeah, we already found several before hackathon. auditors also found. So there, it's something what you want to check. And of course, like everything in memory is padded to 8 bytes. So yeah, maybe we also forgot somewhere to pad it correctly, and it also maybe could lead to strange behaviors or strange execution of the code. That also could lead to different issues, potential issues. Yeah, I would say maybe that's all about VM.
Okay. Thank you for very thorough answer here. Actually, I mean, you said very many interesting things, but yeah, I mean, memory the same thing as it was with the EVM. I mean, how different components of EVM work together and what can you actually do. Same thing with what Green said, maybe also happening with Fuel VM, meaning check how those different components work together. But I have a very similar question, and Wizard, I see your question in the chat. We're gonna answer that in a minute, but I have a question to Rafael because I don't want him left hanging, thinking that I forgot about him, which isn't the case. As you are working on a bridge, what's your perspective on the current audits done on the bridge? Is there any thing that it's not like, of course, there are quite obvious things that you can worry about a bridge, like the bridge failing or everybody can steal money from the bridge, etc. But what are the areas of the functionality of the bridge that you feel could be checked from your own perspective?
So there is definitely one feature of the bridge that I feel less comfortable about. That is when you are depositing any ERC20, there is an option to forward that deposit not to your address but to another contract. And sort of like there are many functions out there on the EVM that allow you to do a transfer and a call in the same transaction, right? So we have a very similar feature in that regard, where the layer 2 bridge, upon a deposit, it will forward the funds to another contract and then reflect that, like call that contract and then maybe do an operation that this contract is expecting, like, I don't know, accrue that deposit. It could be a lending pool, something like that, right? So definitely that's a field that is, if you are a smart contract specialist and you are like very focused on solidity and that kind of things, then that's a green field for you as well.
That's very interesting. Okay, actually, I didn't know about that functionality. Anything else that you want to maybe lead some security researchers into finding some vulnerabilities in bridge? Are there any? Of course, by the way, for anyone listening and later watching on YouTube, we have, if you go to immunify.com and go to the Fuel Attackathon, there will be Learn page, and there are many different learning resources that actually can help you guide you through the code base and the different functionalities from the Fuel network. Please use that as a reference. But of course, one of the main things is always to check if the reality of how application, how Fuel network actually works corresponds to documentation or vice versa. So, because if there may be some discrepancies, there may be potentially a bug. So always please check that. But yeah, Rafael, thank you for that. And yeah, but if you could also mention how security researchers could actually go through your code, meaning where they should start. Are there any like main contract, main file with the main logic, or is it like spread around many different files? I'm asking this because I just want to lead newer white hats, but also more advanced ones to actually better navigate the code base.
Yeah, of course. Like obviously the code base for the bridge can be sometimes, I think it's not as daunting as the Fuel core or the Fuel VM. But yeah, it has several moving pieces, and I can see people getting lost around it. So I would recommend that you make a thorough read of the architecture document that is under the docs folder of the repository, because you have a very extensive explanation of how the moving pieces are in there. And it's actually something that I have been noticing, like many people try to jump directly to the code without reading this document. And then obviously they think that they have found something interesting, but in reality, it's just that they didn't read the document. So it's very important that you go through this document and understand it thoroughly before jumping to the code. And I think that it's also a very nice gateway to the code itself, because you have several links in that Markdown file to the places of the code where the magic is actually happening. Having said that, I guess that I could always start as smart contract developer from the Solidity smart contracts, because it's what's closer to me, and I guess that I could always pull the thread from that point onward. Then I guess that if you have read the Markdown and then checked out the Solidity contracts, you can pretty much paint the picture for what's happening on the layer 2 afterwards. Because in the end, in our current stage, our network is very centralized, and it's in the end proof of authority at the moment, while we develop all the additional gadgets to this centralization. So in the end, it's Fuel core parsing some events from the Solidity side and then putting them on the Fuel chain, where you can do the rest of the stuff. So yeah, I guess that's what I would do.
Okay, thank you very much. Okay, my last question to Jibril. I'm not done with you. Compiler, as you said, is really scary place to have really critical bugs. So any advice from you in which functionality you would actually you yourself start looking for bugs?
Yeah, I was expecting you to ask the same question.
Oh no, I'm being predictable.
Yeah, I actually have something that might be good here. I'm not sure if that's been shared in the links. There is this presentation that we usually do for auditors that walks you through the entire process of the compiler, from the source code to the actual generation of the bytecode. I'm going to link it in the chat because it is public.
Please link it in the chat, but also please link it in the Fuel network channel. Actually, let me do that myself here in the Discord.
I'll let you figure it out, but in the meantime, I'll answer your question. So with this presentation, you should have a good idea what the pipeline is, and at least have an outline of the compiler and figure out where you are in the code base. In terms of what we would like to be more looked at, we've had some pretty serious looks at the optimization and the back end, so all the stuff that does the code generation. That said, this is also where the code is pretty hairy, so there might be some weird behavior of the optimizations that can allow some vulnerabilities. But the thing that has been a lot less looked at is the front end. So anything that has to do with the type system, static analysis, anything that is much higher level, and in some sense actually easier for you to understand if you understand the concept of the language and perhaps not the latter parts of the optimizations. That's pretty greenfield at this point. Not that many people have taken a serious look at it.
Okay, awesome. As we are at the time, there is this one question from Wizan. By the way, thank you, Jibril, for giving this link. I already shared that on the Discord. So guys, please go through that link. But that question from Wizard, which reads, after the 4 taps following this attackathon, are you guys planning for launching on mainnet? I mean, this would be the last audit, or do you plan on conducting other infrastructure or language audits?
I think I can take this one. So I'm not really allowed to say when we're going to launch mainnet, of course. But we are, at this point, I think I'm allowed to say, thinking about doing some more audits. So it's probably not going to be the last one, but we are at the tail end, let's say.
Okay, got it. Thank you. Are there any other questions from the community? Here on the chat, or maybe someone in the Discord who for some reason cannot type here in the Google Meet. I'm monitoring both chats. So far, nothing. Let's give it like 1 minute. But just to wrap up everything, thank you guys for joining. It was a pleasure talking to you. Myself learned quite more thanks to that conversation. Always trying to approach this from the perspective, okay, what I would like to learn. So thank you for answering all my questions, and I hope those questions and answers were helpful to the community. And as I see, we don't have any other questions from the chat on both ends, Google Meet and Discord, so I think we can end. So let me stop the recording. Again, thank you very much. And before I stop the recording, any last things that you want to say? Any advices at the end?
I guess that I could add that on the bridge side, since many people are focused in the contracts, etc., there is also a very obscure part of the bridge itself, which is the predicate contract or the predicate script, which is like the previous step before actually minting the ERC20 that you have deposited on the layer 1. This predicate is built on assembly, on Fuel assembly, which is like the Joule or the assembly of Solidity, right? It's like directly talking to the VM with opcode, etc. So that part being so close to metal, it's also kind of easy to make a mistake in there. So I have been always very worried about this part of the code because it's very gas wolfed. It's kind of easy to assume things that there might be. I don't know. I have always thought that I would want more eyes on that piece of code because it's relatively simple, but it's written again in assembly. It's talking to the VM directly. So that's also, I think, the yummy place to look at.
That's a great advice. Anyone else wants to say something?
Yeah, I want to say that people who will look into Fuel VM also maybe want to look into predicates part of the bridge, because if they look into Fuel VM, they're already more familiar with opcodes. Maybe they wrote already some tests, or they already submitted something like proof of concepts, and they already know how to use assembly, your assembler to write contracts. And maybe it will be much easier for them to read how predicate works and see any potential issues there.
Okay. Any last word from Jibril? I know it sounds terrible, but that's not what I mean here. Any last words for the end of the call?
And I thought I had more time. I don't have much to say. I hope you guys find a lot of bugs, if only so I can sleep better at night.
Okay, so guys, now you know. Please find bugs so the three gentlemen here can sleep better at night, knowing that everything that could have been found was found. So thank you again for everything. I'm seeing if no, there's nothing else. So yeah, thank you. Let me start the recording. Happy hunting, stay secure, and good luck.